Hi there! Let me start by thanking you all for watching this talk. As you can see on the screen, our topic today is a revamp of the event bus on Solidus. We'll see how it looks like and how we can leverage it to extend Solidus. A few words about myself. I'm Marc Busqué. I work with the fantastic team at Nebulab. Since last year, I'm also a core team member in Solidus. My interest in Ruby moved around blending object-oriented and functional programming paradigms. For that reason, I'm a collaborator at Hanami and DryRB. Before diving into serious business, let me start with a trivia fact. As you can hear, I'm not a native English speaker. Because of that, sometimes I wonder about the origins of a particular word in English. When getting ready for this talk, I wondered whether the bus in event bus came from the obvious or had some other semantics. Well, it turned out to be obvious, but I found out a fantastic etymology journey in the process. The first leap leaves us with the hardware-computer buses. As you know, they move data from one hardware component to another. The name linked to the software to describe architectures that communicate parts by sending messages, just like an event bus. Effectively, the name was given as an analogy of buses as vehicles, where not data, but people are transported. Well, that's unless we consider people as data, but in that case we should talk about higher order people. Anyway. Bus is a clipped version of the Latin omnibus. That's what buses used to be called. In fact, in some places like Argentina, they are still called like that. Bus or bus stands for the preposition for, while omni means all. That's for all, but for some reason we decided to keep the part void of meaning. Why were they called omnibus? Well, that's probably a good fit, as they can transport more than a few people. However, the story goes beyond that. We have to move back to 1823 and talk about a man named Stanislas Baudry. He lived in a suburb of Nantes in France. There, he ran a corn mill. Hot water was a byproduct of the mill, so Stanislas decided to build a spa business. However, the mill was on the city's outskirts, if you recall, so he arranged some horse-drawn transportation to bring people to his spa. It turned out that people weren't interested in it, but they did use a carriage to go to and fro. The first stop of the service was in front of the shop of a hatter called Omnes. Omnes was a witty man. He named his shop with a pun on his Latin-sounding name, Omnes Omnibus. That means something like everything for everyone. Therefore, people in Nantes started to call Omnibus to the new service. So, it turns out we call it the event bus because presumably the parents of Omnes gave him that name. By the way, Stanislas, the guy of the mill, closed both it and the spa to run his service. Eventually, he moved to Paris to earn more money in a bigger city. Alright, that's been enough. Let's move on to why you're here today. We'll structure this talk into 3 sections. To begin with, we'll survey the different options we have to extend Solidus. Later, we'll talk about event notification in general. We'll end the talk by glancing at the interface for the event bus on Solidus. Let's start with the first point. There are different ways Solidus functionality can be extended. We'll look quickly into all of them: custom service classes, monkey patching, and the event bus. Some parts of Solidus default behavior come encapsulated in standalone classes. Those can be switched by custom ones to extend or replace the default behavior. The place to specify custom service classes is the spree initializer. Here we are tweaking how adding an item to the cart works. Imagine creating a particular store where it only makes sense to buy a single item for any particular product or variant. We can customize the so-called order contents class. We inherit from the core one, but we create a custom implementation of the add method. It returns and does nothing when a variant is already present in an order. Otherwise, it falls back to super and hardcodes one as the quantity argument. Service classes are a very clean way to extend the core behavior. However, not every piece of the business logic is encapsulated. In those cases, Ruby's metaprogramming powers come to the rescue. For instance, imagine we want to force a minimum of $30 to proceed with the checkout. We have no other option but to override the checkout allowed method on the order model. By using prepend, we are still able to call super, as a prepended module ends up being at the top of the ancestor chain. There are other ways to perform monkey patches like include, class eval, and so on. But prepend gives us the most flexibility. We also need to configure Rails to autoload monkey patches files. That's what we're doing here. However, we need to be very careful before going down that path. Monkey patches are not actually extending behavior. They are replacing an implementation. Often they come as a duct tape solution. Whenever you feel the need to monkey patch, you should ask yourself first if there's a longer but safer road to take. For instance, that could hint at a missing encapsulation from your domain model. Or if that's something that makes sense for any store, you could consider submitting a pull request to Solidus. Monkey patches can break upgrades, as a method can change or be removed with a new release. Lastly, we have the event bus. It's a publish-subscribe pattern to extend behavior independent from the core domain model. Here, a subscriber module sends an SMS whenever an order is completed. We're not going to look into it in detail now, as it's a topic for the rest of this talk. And that brings us to the next section, where we'll talk about event notification in general. We'll see its pros and cons and learn when and how to use it wisely. We'll end this section by comparing the general pattern against the implementation on Solidus. So, what is event notification or an event-driven design? Consider this example. We have a user who has just placed an order. Our store has several systems that need to perform an action when that happens. For instance, the statistics system needs to register a new conversion. The accountancy system needs to add a sales invoice. Because of that, the order system is calling the appropriate methods on all of them. What's wrong with that? It might be nothing for small systems, but it can quickly get out of control. The main problem we have is coupling. The order system, which is something at our core model, needs to know about the API of all the affected secondary systems. It needs to know that others need to know about itself. If we rename the addConversion method, we need to update the order system. We also need to update it if we add a new dependency. How to fix that? Look now, we've introduced a middleman, the event bus. When an order is completed, it sends a message about the event to the bus. In turn, it dispatches a message to all interested parties. They had previously asked for a subscription for that particular event. What downstream systems need to do is no longer of the order system concern. Basically, we've done a dependency inversion. The order system is no longer coupled with the other ones. It still needs to know that a middleman exists, but it's no longer affected by the API changes or the addition of a new system. Let's repeat it. The main benefit of an event bus is decoupling. There's, however, another interesting result. The changes get bundled in an event, which opens the gates to interesting ideas like persisting them or using them for debugging purposes. A relevant question is, how much upstream data do we publish? If we only publish a small piece of information, like some identity, the downstream services might need to query back for more details. On the other side of the spectrum, we can transfer the maximum amount of state. However, inconsistency could become an issue. Lastly, we can build events around all the data that change throughout the system. That's to say, using event for everything, which is the backbone of event sourcing. That goes much beyond the scope of this talk, but event sourcing allows exploring things like in-memory state or alternative state, and it's also great for debugging. If that looks weird and unfamiliar, notice that control version systems like Git are precisely that. But if events are so cool, why don't we use them for everything? As always, there's the other side of the coin. The main problem with event-driven design is that it introduces indirection. If you want to know everything that happens when an order is completed, you must search for all subscribers to the event. That makes testing and observability more complex. A direct consequence of decoupling is also message delivery issues. So, when should we use it? I like to take the example of domain-driven design because it makes it pretty clear. In DDD, we name bounded contexts to the boundaries where a given domain model applies. Think of order, accountancy, and statistics systems as different bounded contexts. In turn, bounded contexts are divided into aggregates. They are like inner walls built around models that operate within the same transaction. A message mechanism, like an event bus, is one of the options to perform the so-called context mapping. That's to say, communication between different bounded contexts. Often, it's reused to communicate different aggregates within an individual context. Both situations have in common that they run in different transactional boundaries. In the most common implementation, that means running in different database transactions. Martin Fowler gives super helpful advice about the dangers of what he calls passive-aggressive commands. If an upstream system really wants something to happen, it should tell it directly, instead of insisting through a middleman. For example, sending an email or collecting stats after an order is completed are good candidates for event communication. However, if something needs to be done before marking an order as completed, like checking the user or adding a free item, that should be a one-to-one conversation. And that gives us everything we need to know how we should design subscribers. To begin with, it helps to think that many event notification systems are designed in an async way. That means listeners should be designed independently from the upstream process. Many messaging systems are designed with an at least once delivery strategy. That's to say, a subscriber would run at least once, but potentially 1 million times, so ideally our listeners should be made idempotent. Lastly, as upstream and downstream services could be running in different systems, we should consider latency or any other timing issues. In general, subscribers should be fault tolerant. To end with this section, let's look at how that relates to the event bus implementation on Solidus. Our setup is very simple. The events are not backed by any well-defined type. Instead, they are freeform. You fire an event and add whichever payload you want at that time. That implies that event storage is not supported, as there is no defined way to serialize to a database. Another aspect is that the event bus on Solidus runs synchronously. Serialization is also a reason for that. Still, it also makes it agnostic to whichever adapter a user could build, for instance a sidekick adapter. The trade-off is that it makes it too easy to cross boundaries. It's the developer's responsibility to build a good architecture considering what we said. That ends with the exposition about event-driven architecture and brings us to the last section. We'll now present the event bus interface on Solidus. We'll begin with the basics features, saying how to publish and subscribe to events. We'll also look at the benefits of event registration and the help Solidus offers to test and debug events. In the end, we'll give some notes about what to expect in the future when it comes to the Solidus event bus. We've already seen how to fire an event on Solidus. We provide the event name and a free form payload. To subscribe to an event, we can create a subscriber module. It needs to obey 3 conditions. It must be defined in a module within the app subscriber directory. It needs to be named with a subscriber as a suffix, and it needs to include the spree event subscriber module. Those modules will be automatically loaded by Rails. We define the event handler as a method in the module. That method needs to take an event object as an argument. It allows us to access the payload. Combining the event action class method and its event name option, we match the event name with the handler. If we don't give the event name option, it's expected to be the same than the method. However, we also can directly subscribe a block of code. We just need to call the subscribe method on a spree event, which will yield the event object to the block. It's also possible to subscribe to a set of related events using a regular expression. That was all for the basic publish and subscribe features. However, before doing that, an event needs to be registered. This might seem like an unnecessary bureaucracy, but the benefits are twofold. On the one side, it avoids subscribing to invalid events. For instance, it saves us from a typo. On the other hand, it also avoids name collisions between Solidus core events and custom ones. Events need to be registered at the end of the spree initializer. That's because the events need to be available before the subscriber modules are loaded. Let's move on to how to test the event-driven behavior. The Solidus event bus is a global bus. All events are published to the same instance. For this reason, we need a way to scope the execution of some code to the listeners we want to test. The performing only method will silence all subscribers except for the specified for the duration of a block. However, before using it, we need to enable the test interface, as we are doing here in the rspec helper. Performing only can take a subscriber module to listen to all the events that the module subscribe. A more fine-grained control can be achieved by calling the listeners method on the module. Lastly, performing only can also take the return listeners of a blog subscription. Not shown here, but a specialized method called performing nothing also exists, which allows us to completely silence the event bus. Last point about event testability. For those who feel more comfortable with stubbing, there are some event helpers to make it straightforward. We need to include the event helpers module in our test file. Then, after we call a stub spree events method, we can assert that a given event has been fired. It also allows chaining with to match the published payload. To end with the event bus interface, let's talk about the observability facilities. They come as handy when debugging, tracing, logging, or whatever. Besides the payload, an event object gives access to a couple of meta attributes: the event firing time and the event caller location, that's to say its publisher. On top of that, a firing object is returned when an event is fired. It gives access to the event and the array of execution it triggered. For each execution, we can inspect its execution time, its associated listeners, the result of the execution, and a benchmark of it. As ending notes, let's briefly sketch what to expect about the new event bus in the near future. We're still working on the docs, but they will be ready very soon. The most significant development will be the addition of new events. That will give the host application more opportunities to hook into Solidus and extend it. Lastly, at this point we're still supporting the alt adapter, but you will see a bunch of deprecation messages if you use it. Most of the new features we've been talking about here are not supported in the alt adapter. Our plan is to remove it altogether on Solidus 4.0. Well, that's been pretty much everything. I hope you enjoyed it. By the way, in this repo, you'll find the slide for this talk. If you have any questions or suggestions, please don't hesitate to reach me or any other member of the Solidus core team. I wish you learned something new besides the origins of the name bus. Thanks again and see you next time.